Hey, True Class, let's look at this problem from the 7.8 homework set. So we're told here that we're going to use a sine wave to model the number of hours of sunlight in some unnamed city. But we're told at summer solstice, which is the most sunlight we'll have, that's the peak of the sine wave, we'll have about 15.832 hours, and then at winter solstice, the minimum number will be 8.13. Now, or 8.316. So we're told this is the max. That's the biggest number. So there's 365 days in a year. Let's say there's 365. So that's like one full period, no matter where we are at time zero, somewhere in between these two. And we go up and we peak and we come back down and then we go back up again. When we get to that height that we started from, right there, something like that, that would be a full period. And what we're told is at somewhere around the 172nd day, we're at our peak. All right, now if a full year passed and we got to 172 plus 365, which is 537 days, we would be right back to that summer solstice approximately with the way this sine wave models. And that is a full period, 365 days. But what we also know from, that's just straight up from the cosine wave. If we start at 0, we go to 2 pi, that's a period. That's maximum to maximal on the cosine wave. But half of a period, when we get to that minimum, so from there to there, that's half a period, that'll get us to that minimum point. All right, so that would be 172 plus half of 365. And that occurs at around 354.5 days when we get to that half a period, that minimum point. So that's how we can use this. But now what we have to understand is this is not necessarily at 0. That's not necessarily going to be our midline. And this is not necessarily, that's kind of deceptive. It's not necessarily going to be on the y-axis. When we go back 172 days, it's not necessarily going to be it will be the y-intercept, but it won't be necessarily the midline, is what I'm trying to get at. But what we have to do is figure out the midline, and we can do that by the average of these two. That'll give us the line that cuts this thing right down the middle. And the reason why that's so important is because halfway between the max and the min is the midline intercept. Halfway between the min and the max is the midline intercept. And if you recall, this is the way the sine wave begins. It starts at its midline, and it rises and then falls and then goes back to the midline. Right? Or we could do it from this one. It rises, falls, and then goes back to the midline. But no matter what, we have to, because we're modeling with a sine wave, we have to use those midline intercepts. All right, so let's do the math. What would the midline be? That'll be the value of B over here. So the midline is the average minimum and maximum value. So if I average those, I get 12.074. Okay, that's the equation that's the height right there in the middle. That's also the value of B here. All right, now amplitude. The amplitude is the distance from the midline to the max, or the midline to the minimum. But the easy way to find amplitude is to just subtract max minus minimum and then divide by 2. So that's 3.758. Again, that is the amplitude. Okay, so that is the value of A here. All right, I'm going to move some stuff over. All right, so there's the number now in front of the sine. All right, now we're on to the stuff on the inside. So we got omega that is controlling the period, and then we got this value for phi here that is determining our phase shift along with omega. So the way we're going to do this is the period, the calculation for period, 2 pi divided by omega is equal to the period. All right, that's the calculation for period. Well, our period, we're told, is 365 days, because it takes, we go from maximum summer solstice to maximum again at the next summer solstice a year later. So that's 365 days later. So do a little math, rearrange this, basically omega and 365 change places, and we get omega is equal to 2 pi over 365. All right, now to make this calculation a little easier, I'm not going to do phi just yet. So I'm basically doing, I'm just going to call it C. I'm basically doing this shifted version. Phi will be what we get when we distribute the omega, this 2 pi over 365 back through. But for right now, to make the math a little easier, we're going to leave it in this form. All right, so if this was not shifted, if c were 0, what happens is we have this sine wave, and it would bounce up and down. This would be, there's my midline. It would bounce up and down like this, but this would be 0, 12.074. This would be 365, 12.074. And this value right here would be 365 over 2, 12.074. All right, and that means this value right here, where the maximum is supposed to occur, would be 365 over 4, 15.832. All right, 365 over 4 is 91.5. All right, that's not what we want this to be. So we need this to be shifted over to 172. So that means we need this point right here, we need it to be 80.75 units to the right. So that's the shift that we have to do. We have to subtract 80.75 to get that calculation to work out. All right, so there is our base model, but what we're going to do is distribute this 2 pi over 365 through, and then we're going to simplify that to a fraction. All right, and then distributing this through. Like you see in a lot of these videos, it's made easier if I do 80.75 times, leave the pi off, 2 divided by 365, hit enter, change it into a fraction, all right, and then I stick pi back in there. So 323 pi over 730. And then I add to that the 12.074. So that's the way that I would approach this problem. I do know my math lab is going to want these two values to be exact in terms of pi. If you look at the instructions, it tells you that it wants an exact answer in terms of pi. So that's what we're going to put in here. So there's all the different values. I'm going to check my answer. That's good. And then it wants to know, use the function to predict the number of hours of sunlight on April 1st. So there is a job again for your calculator. So I would go here, I would go into Y1. So there's my model, it's added in there. I'm going to press second quit. I'm going to go back to the main screen. I'm going to go to VARS, V-A-R-S, it's right here. To the right to YVARS. Option number 1 is function. That's what those Y's are. And then Y1 is the function that I want. And I want to put in the number that it says. So the 91st day of the year, so I put in 91 in there. And there's what I get. So 2 decimal places, I would have 12.73. All right, finally, the last question wants me to graph it. So I'm going to click here. All right, click the correct tool. So this is a sine wave, so I'm going to click the sine button. Anywhere, plot it in there. It wants to know what's my amplitude. So my amplitude is that 3.758. My period is 365. All right, my vertical shift, it's the midline, so that's 12.074. And then my horizontal shift. So the horizontal shift, the phase shift, is actually phi divided by omega from that original formula. If it's to the right, then we do a positive. If it's to the left, we do a negative. So if you look at my work here, this number was what I had before I distributed that through and simplified it to this number. That's the actual horizontal shift, right? The period, the 365, we've already dealt with that, which when I distribute through gives me this number. But this is the actual horizontal shift. So it's not this number that we're after. It's this number divided by this number, which will be that 80.75. So I'm just going to write it as a decimal. All right, and then check my answer. So make sure on that last problem that you aren't just using the simplified. Basically, your answer to part A, a lot of people want to put this as their shift. That's not your shift. It's the number that you have there divided by the 2 pi over 365.